Hello and welcome to this video about isometric and perspective views. So what is isometric and perspective views? Now in this example I'll take two cubes. So cubes have parallel edges and when they are drawn parallel even on a paper, that is called as the isometric view. When the edges are drawn in such a way that when they are extended, it meets a point, it is called as the perspective view, as you can see on the right side. Now, the point where these edges seem to meet is known as the vanishing point. So where should we use isometric view and where should we use perspective view? First, let us understand why we need to see in perspective at all. So perspective is a way in which a human eye is able to tell how big the object that we are viewing and how far away we are from it. So in this example, you have two cubes. The first one is an isometric view and the second one is in perspective view. Now doesn't it feel that the second cube, the viewer, that is you, is much farther away? And if one of the cubes were to be made a dice, won't the one in isometric view look much more suitable for a dice than in the perspective view? And that's because perspective views are much more pronounced for larger objects. And that's why you see roads, buildings and all these things which are much larger than the scale of a human in perspective. But for a dice, the points of perspective are so far away because it's much smaller than the size of a human being, it can be almost considered to be in isometric view. So now these two buildings, both of them are in perspective. However, the second building seems to be much taller than the first one, even though the height on the paper is same. And the reason being that the vanishing point is much more closer to the object. So that would mean closer the vanishing point is to the object, the taller it will seem. Another characteristic of perspective views is the size of objects compared to one another. So here I'll be using 1-point perspective, but we'll discuss this in detail in the next video. So you have these cubes which are lined up, and the cubes as they approach the vanishing point get smaller, and the cubes which are closer to the viewer and farther from the vanishing point appear to be much bigger. Also notice the vertical gaps. As the gaps approach near the vanishing point, it gets much smaller. Now, does it mean that all the objects in the composition should follow or share the same point of perspective? What if we were to rotate one of the cubes here? Now it follows a completely different point of perspective. It is in 2-point perspective actually, and all the other cubes are in 1-point perspective. Even the locations of the vanishing points are much different compared to the previous one. So what does this mean? Basically, only objects which have parallel edges and objects which are placed parallel to one another can share the same point of perspective. In the next videos, we'll discuss 1-point, 2-point and 3-point in further detail. That's it for this video. See you in the next one.